The question we're trying to answer today is how strong is the Coanda Effect? Sit tight and dive deep with us today on our research. This is our team. My name is Rosana and I'll be guiding you throughout this study. You must be really confused, thinking, how am I watching a study about something I know nothing about? First of all, let me explain what the Coanda Effect is. In few words, it's the tendency of a fluid jet to stay attached to a convex surface. And don't worry, till the end of this video, I promise you'll know what this means. Let me begin with a practical example. As you can see in this short video, when the spoon touches the water stream, the water starts to bend and counters the shape of the spoon, dripping as a curve. You know when we're trying to pour a liquid and it counters the cup and drips all over instead of going the direction we're pointing? You should now know that this is only possible due to the Coanda effect. That is, the tendency of the fluid, in this case is water and coffee, adheres to a surface, in this case is a spoon and a mug. Long story short, the fluid doesn't go the way we expect, but makes a new way contouring an object. The fluid we chose to use is air. And although we cannot see the effect, it sure can be perceived. As you can see on the video on the right, even though a bottle of wine is put in front of the candle, the man can still blow it out. That's because the air counters the object and reaches the candle at the end. One of the reasons that airplanes are able to fly is that the air counters its wings, making possible the pressure difference on each side. But we're not here today to learn about planes, so let's get to the point. We chose to make our experiment to analyze the strength of the Coanda effect using a hairdryer, different sizes styrofoam balls, and at some point we aggregate mass to the balls with metal nails. This is how our basic experiment looks like. So you can see that the ball is suspended by the air flux and that it can be maintained in the air even when we tilt the hairdryer in a very wide angle. This is possible because of the air contouring the ball, but at some point the ball falls. That's exactly what we're trying to understand. How strong is the Coanda effect? And to comprehend that, we'll see how differences in the object being studied cause to strength. But how exactly are we measuring the Coanda effect strength? Well, we started with 6 different ball sizes. And to be able to test different masses maintaining the spheric object, we added 5 different metal nails that had different masses to our balls. To begin the experimentation, we measured the ball's maximum height. Then, the maximum angle they could sustain without falling. We collected all the data, meaning we measured every ball with every metal nail with every possible velocity. For our bad luck, we got much less data than we expected. Most of our results were taken on the higher velocity, and the bigger balls and smaller ones were highly unstable and couldn't hold on to any angle or even fly properly at 0 degrees. But we could reach some conclusions. As you can see on this graph that targets weight and maximum height, the bigger sizes, deep red colored, suffer little to no alteration, maintaining the same height almost in every change of weight. However, the 50mm ball had a constant drop in height as its weight increased. As for weight and maximum angle reached, we can see the same pattern on our results. For the bigger balls, we had little to no alteration, and for the 50mm ball, there is a constant increase in angle as its weight increases on the higher velocity. But the main thing we can notice is that the bigger and heavier balls are more stable than the others. But what does all that mean, am I right? So, answering our main question, the Coanda effect is strong enough to support wider angles on heavier and bigger objects than smaller and lighter ones. So the dependence of the Coanda effect strength is more related to changes in weight than changes in diameter. Since the bigger balls had little alteration in mass, but were still the heavier ones, we could not see properly what would happen if they had bigger quantities of mass increased. So as our project is over, we leave that up to our fellow scientists. We hope you've learned something new today. Thank you for watching.